live. Sweet. So, did anybody have any questions on the preparation assignment? Or can we just go straight to the quiz?
I don't mind if we go straight to the quiz.
That's my favorite answer.
How about you guys, Kelsey, Ricardo?
I'm good. We can go to the quiz.
Yeah, I prefer to work on the quiz, and after that, review everything.
Sweet. Let's see how well my screen share is going to work today. This one.
Let's see.
Can everybody see that?
Yeah, wow, we have 20.
20. But they're not hard at all. So if everybody has the categorical data analysis on, there's a lot of things can go a lot faster. So starting with number 3, let P1 be the proportion of females in the population who can taste PTC, and let P2 be the proportion of males in the population who can taste PTC. The research question for the study is given here. Is the proportion of females who can taste PTC different from the proportion of males who can taste PTC? So use the data in the table to find P hat 1. So that'll be 52 divided by 70, which is N1. Let me look at my calculator.
So can we use Excel for this one or no?
We could definitely do that.
Do you know which one is going to be?
What do you mean? Which Excel?
Yeah.
Categorical data analysis.
Okay.
Oh, my computer is freaking out with the calculator. I'm not really sure why. Calculator. There you go. So I got 0.743 for P hat 1.
That's what I got.
Yay! And the other one is 42 divided by 59.
I got 0.712.
That's what I got.
Perfect.
Okay, what was the research question? Is the proportion of males who can taste PTC different from the proportion of males who can taste females who can taste PTC? So H0 for two proportions is always P1 equals P2.
Mm-hmm.
And so the alternative for us will be P hat 1 does not equal P hat 2.
Yep.
Right?
Yep.
Hold on a second. Okay. Wait, no. It's not the fourth one. It is the first one. Because we're not looking at P hats. We want proportions.
Oh, you're right. Yep.
Haha. He tried to trick me, but I'm too smart. Alright. Let me see. Okay, how many females? I'm opening Excel and I can't look at them both at the same time. How many females can taste PTC?
52
52 out of
Mhm.
70, right?
out of 70, yeah.
And then how many males can taste it?
42
Out of
59.
out of what?
59.
59. Not equal. 95% confidence value. All right. Okay, sweet. All right. Somebody want to take on? I'm not. How do we do the confidence interval? Why am I so confused at this?
Okay. Well, okay, I'm just making sure. Is the type of test P1 does not equal P2? Is that what we put for the type of test?
Yes.
Okay. So when I put it into Excel, it gives me two types of confidence intervals, so I don't know which one it would be.
Right.
I get negative 0.123 and then 0.183. I guess, okay, yeah.
So how are you putting the values in the inputs?
So this is what I'm using. Can everybody see this? Is it working?
Yes.
Okay.
So,
Awesome. So here it's I don't know what it's saying. Exactly. I'm very confused.
I think it's going to be 0.185 minus 0.123. I think.
It's gonna be what? Sorry.
It's going to be 0.185 minus 0.123, I think.
Kelsey, the second number that you got was 0.183, right?
The 185, sorry. The first one
0.185.
was negative 0.123. I got the same numbers as Justin.
Yeah.
1, 3.
Trying to read in the text to see if it.
So it talks about confidence interval in section 3. If that helps. Oh, well, that's an intense equation for confidence interval. Okay, so it's just all it is p hat 1 minus p hat 2 minus the z-score, and then plus the z-score.
Yeah.
Minus the z-score times all those things. Oh, I'm confused.
Do we add them?
Add the what?
Wait, let me look at this better. Okay, so this is the lower bound of 95% confidence interval for the difference of the proportions of times Fox prints are observed in the same factors.
I think we're talking about number 6 right now, right?
Yes.
Yeah.
I think it's going to be 0.309. I think we had a question like this in a previous quiz.
I feel like I feel like I have no idea actually. Thought I had ideas, but I don't. Sorry, false alarm, guys. I just still have no clue.
Okay, I think we should just go with what Ricardo's suggesting.
Okay.
What you did, Ricardo, is you just subtracted them.
Yeah, because that's going to be the middle, you know?
Okay, let's do that, and then we
So
have a
what?
few tries, and if it doesn't work out, then we'll try to figure it out.
Yeah.
So what did you say, Ricardo?
So I'm saying that if we take 0.185 minus 0.123 is going to be the point estimate for 95%. Because that's going to be the middle, you know?
So is that going to be 0.062?
It's 0.309.
Oh, because the thing is that there's a negative.
Oh, so we're adding them
So, yeah.
because it's a negative. So wouldn't
Uh-huh.
the
Unless we do...
what does it talk about point estimate? What does that mean?
It's like, if I remember, it was like the middle between both.
So would it be 0.308 divided by 2? So it's in the middle of them?
But isn't point estimate like...
That was like, I think 3 weeks ago. I can't remember.
Point estimate. Point estimate. What does that mean?
He came in a quiz.
Okay, so in statistics, point estimation involves the use of sample data to calculate a single value, which is to serve as the best guess or best estimate of an unknown fixed or random population parameter. More formally, it is an application of a point estimator to the data. So like when we don't know the population parameter or something, it's, I don't know if that helped, but that's what Google told me. Let's see. Point estimates and confidence intervals. I say we just go with what Ricardo's saying because none of us have any other better option. And then from there we could, after we're done with the quiz, if it's wrong, we could try to figure it out.
Yeah, but you know what's the thing? Like 0.309 is like greater than 0.185.
Oh.
So here's what I'm saying. Here's what I think. I'm gonna say 0.154, which is the middle of those two. It's adding them together because one is negative and then dividing by 2. So that the margin of error can be... Nope, I'm wrong. Again, I think that's margin of error. So it'll be point.
Let me check in a previous quiz because I know that we did it before. Check.
Hey, I'm also, like, I'm seeing, I went to Cliff Notes, and I'm seeing that the point estimate is right in the middle of the bell curve. Like, where 0 is, that's like where the point estimate is.
Uh-huh.
So maybe it is subtracting it? I don't know.
Because that's what I was doing, like subtracting, but that's giving me like 0.309 that is greater than 0.185.
Okay, here's what I'm doing. And you guys can do whatever you want because I'm probably wrong. So the confidence interval, I took the lower bound, which is negative 0.123, and I added 0.154, which is half of 308, which is what I got to, which I think is the margin of error. Does that make sense? So I'm going with 0.031.
Okay.
So that's what I'm doing for number 6. And then for number 7, I'm going with 0.154.
Okay, let's try that. Okay, so which one is for 6?
6, I had 0.031.
Okay.
For 7, I had 0.154.
Okay.
So the lower bound, it says is negative 1.123, which I recognize is impossible because you can't have a negative proportion, but we'll ignore that. What Excel is saying, so let's do it. And then the upper bound, according to Excel, which suddenly I'm in doubt of, is 0.185. And then for question 10, I'm saying fail to reject H null.
Yeah.
Okay.
Which of the following statements best describes the outcome of the study? There is insufficient evidence to suggest the true proportion of females who can taste PTC is less than the true proportion of males who can test PTC. There is sufficient evidence to suggest that the true proportion of females who can test PTC is greater than the true proportion. Okay, let's see what it says. Okay, the third one is there's sufficient evidence to suggest that females who and the original So we had said for number 5 that P1 is not equal to P2. So I think for this one it should be.
I'm sorry, I totally spaced for a minute. Which question are we on?
We're in number 11.
Okay.
I think it
I
could be B.
I think it is because if you look at the p-score, it's the p-value. It's 0.653, which is way more than 0.05.
Yeah.
And so I said that there was insufficient evidence to suggest that the true proportion of females who can taste BTC is different from the true proportion of males who can taste BTC, the last one.
Yeah, it's insufficient
Yeah, that makes sense.
and different.
Number 12 is true. Let's get that out of the way.
So it's definitely not the third one.
Or the second one, because there's not sufficient evidence to say anything.
Yeah.
And then the first one, that's not what we were testing for. We were just testing to see if it was different. So while it's true, it's not the one that best describes the outcome. Does that make sense?
Mm-hmm.
So do we agree on the last one?
I agree on the last one because that's the one I picked.
Yeah, let's try that one.
Is it data in this paper to find P1?
Do.
So 14 is going to be 0.141,
That's what I got.
and then 0.145.
Right. Then the z-score is 2.02.
With a minus?
Yes. Would it matter?
Probably yes in the answer.
Okay. Yes, it would. Yes, it would. Left or right? To the left.
Sorry, is 16 negative?
Yeah, it's minus
Yeah.
2.
Okay.
$17, it's to the right, right?
Left.
I said to the left because it's less than.
Oh, right.
And we can reject the null because the p-value is 0.022, which is less than 0.05. $20 is the third one. Wait, let me reread it. Weekday is less than the proportion than the weekend. Yes. 20 is the third one.
Yeah, reject sufficient.
Okay. I'm going to submit my quiz.
Wait, probably too messed up.
6 and 7 probably wrong. Let's see. Haha! We got it right. 6 and 7. I was correct. Look at that. For the
Awesome.
win.
So how do you do
100%.
that? How do you do that? Just to make sure.
Your
Okay.
face of astoundment is awesome.
I was
Yeah,
very
yeah.
surprised.
Yeah,
Okay, wait.
121.
Let me
Let's go
let me
back to
remember what
that.
I did.
So
Okay.
I remember you divided the bigger number and then you just added the negative 0.123.
Okay, so I found the difference between the upper bound and the lower bound.
Uh-huh.
I divided that by 2, which gives us our margin of error.
Uh-huh.
And then I just took our margin of error and added it to the lower bound. So I just found margin of error, went to lowest bound, and added the margin of error so we could find the middle. Does that make sense?
Yeah.
Okay, so what was the middle in that case? 0.062? No.
0.031.
Okay.
Because it was 1.185
Uh-huh.
minus negative 0.123, which is just adding. And so that gave us 0.308 divided by 2 gives us 0.154, which is our margin of error. So I added that to the lower bound, or you could subtract it from the upper bound. Does that make sense?
Uh-huh.
Okay, so I have 0.54. Okay, I'm going to make a note here. Uh-huh.
Can you explain it one more time so I can write it down for future reference?
Yeah, actually,
Yes.
I'm adding that to my chart.
Okay, so here's how I got it.
So F21. Okay.
So the Excel sheet gave us our lower bound and our upper bound, right?
Uh-huh.
So I found the difference between those. So in this case, it was 0.185 minus negative, so plus 0.123, which gave us 0.308. That's the difference between the two. So then I divided that by 2 to find the margin of error. So that was 0.154. So I just went the lower bound and added the margin of error to give us right in the middle. And I feel like it's just the true mean that we found, the sample mean. Now that I'm thinking about it, that's a way easier way to do it. What I did was really complicated. But that's just what I did with the numbers straight from Excel sheet.
Okay. Hey guys, really quick. What's number 18?
I can tell you because I got it right.
18 is 0.022.
I got 0.022, and it's correct because I'm a winner. Guys, you don't know how excited I am that I figured that out because I
Okay.
truly had no idea.
Number 19? Number 19 is fail to reject, right?
Number 19 is
No,
reject because the p-value is less than 0.05, so we know for almost sure.
Okay.
We are the champions, my friends.
Like for me, to be honest, like all these quizzes are not that hard, but in the exam, all the time in the exam.
Right?
Yeah. I'm like, for real? Why not the
Awesome.
same thing in the quiz?
Why can't you just give us exactly the same questions?
No, I'm
That'd be
always
excellent.
struggling with exams like bad.
Uh-huh.
Hey guys, what did you get for number 7? Because I got
Let
it
me look.
wrong.
0.154.
0.1?
Yeah.
0.154.
Oh, okay. Yeah. I typed in by accident 1.54.
Oh, well, that's very different.
Yeah. 7. Awesome.
Awesome.
Hey, Justin, by the way, thanks so much for taking care of the design of the study, for taking so many hours to do that. And that was super thorough, and it was great.
Okay.
Thank you.
Awesome.
Yeah, that was awesome.
So, and if he says that I'm wrong, perfect. But then it's somebody else's job to figure out what's right because because I got really confused. Anything else we need to go over?
I think we're good.
Yeah, I
Awesome.
think we're fine now.
Awesome.
So Wednesday?
Wednesday.
Okay, sounds perfect.